Ladies and gentlemen, in this video, we're going to talk about how to multiply and divide with scientific notation. Now, if you're also looking for addition and subtraction with scientific notation, I'll leave that video link down in the description for you. And without further ado, let's go ahead and get into the lesson.
I never sleep, I never eat, I never leave my house alone. Another evening in between what I believe and what I know.
Now, for multiplying and dividing with scientific notation, the very first step that we want to do is we want to regroup our coefficients, which are the numbers out front. So for number one, we have 4 and 5 and 21/100ths. Those are our coefficients. We want to put those in its own parenthesis, and then we want to take our powers of 10 and put them in their own parenthesis as well. And we can do that because the associative property allows us to do that. So let's go ahead and do that first. So we have in one parenthesis 4 times 5 and 21/100ths. And then in the other parenthesis is going to be our powers of 10. So 10 to the 6th times 10 to the 2nd. Now with the associative property allowing us to do that, we can go ahead and move on to step 2, which is multiplying our coefficients together. So let's do 5 and 21/100ths times 4. Now one thing I like to do with my multiplying here when it involves decimals is I always count how many numbers are behind the decimal point right off the bat. And in this case, we have 2 numbers behind the decimal point in total, which is the 2 and the 1. And all I'm going to do is on the side here in parentheses, I'm going to put the number 2, and I'm going to completely ignore the decimal point when I multiply. So we're going to do 521 times 4. And now let's multiply. 4 times 1 is 4. 4 times 2 is 8. 4 times 5 is 20. And that 2 in parentheses tells us at the very end we should have 2 numbers behind our decimal point in our final answer. So we're going to end up getting 20 and 84/100ths for the first part. So let's go ahead and get rid of this. That way we have some room. And this was 20 and 84/100ths. Now let's go ahead and focus on our powers of 10. Now for our powers of 10, properties of exponents says if we are multiplying with like bases, in this case we have like bases because both bases are 10, all we have to do with our exponents is simply add them together. So what is 6 plus 2? Well, that's going to give us 10 to the 8th. So we end up getting 20 and 84/100ths times 10 to the 8th. The only problem is that this isn't in proper scientific notation because your coefficient or the number out front has to be greater than or equal to 1 but less than 10. And this one is definitely larger than 10. So we need to adjust it by moving our decimal point 1 place value to the left. Because if we do that, it's now going to meet that range that we need, greater than or equal to 1 but less than 10. So we now have 2 and 84/1000ths times 10 to the, and you can't just make that decimal point change without something else being affected. So we just made our number go from a larger number to a smaller number by moving the decimal point 1 place value to the left. So if we're making our number smaller, in return our power is going to do the exact opposite and actually increase by 1. So this is going to be 2 and 84/1000ths times 10 to the 9th for the first one. So this is our final answer. Now let's go ahead and take a look at a division problem in number 2. So very, very similar. We first want to regroup our coefficients, which is 2 and 4, and our powers of 10 together. So I'm going to do that on the side here. So we have 2 over 4, and then our powers of 10, that'll be 10 to the 5th over 10 to the negative 7th. Now let's go ahead and divide our coefficients this time because it's a division problem. So we have 2 on the inside, 4 on the outside. Well, 4 doesn't fit into 2 at all, but we're out of numbers. So I'm just going to extend this out. And we're going to add in a decimal point and a 0. And I'm going to move that decimal point up into our final answer or our quotient. We know that 4 didn't fit into 2 at all, so I'm just going to put a 0 there. 4 fits now into 20 5 times perfectly. 4 times 5 is 20. We subtract, we get a remainder of 0. So now we're working with the decimal of 5/10ths for the answer for this first part. Now, what's different about our like bases here, it's now set up like a division problem. So properties of exponents says that if we have like bases and we're dividing them, we don't add our powers this time, but we subtract them instead. So we need to do 5 minus negative 7. So if we did 5 minus negative 7, you can't subtract a negative. Instead, it actually turns into addition here. So it's going to be 5 plus 7. So we're going to end up getting 0.5 times 10 to the 12th. But once again, our coefficient doesn't fit in the range that we need, so we need to adjust our place value here by moving the decimal point once to the right this time, so we can get that number into the range that we need. So this is now going to be 5 times 10 to the, but this time around, we made our number larger for our coefficient, so we moved our decimal point one place value to the right. But in return, our power is going to actually decrease by 1. So notice how they're opposites every time. So our final answer is 5 times 10 to the 11th. Now let's go ahead and take a look at number 3. But you're going to notice something's a little bit different here. One of these is in scientific notation, but the other one's in standard form. So we need to adjust this by moving the decimal point to get a number that's greater than or equal to 1, but less than 10. So we need to move this once to the right, twice, 3 times, 4 times, and we're going to get 2.6 times 10 to the, and we just did this in number 2. We moved the decimal point one place value to the right and our power decreased. So we just moved this 4 to the right, which means our power needs to decrease by 4. So this would be 10 to the negative 4th. Now that they're both in scientific notation, we can go ahead and regroup these now with the associative property. So 6 times 2.6, our coefficients are together. Now let's go ahead and put our powers of 10 together. And now we're going to do the same exact process just like we did in number 1. Let's go ahead and multiply our coefficients together. Again, I'm going to put that number in parentheses on the side. This time around, though, it's going to be a 1 because there's only one number behind the decimal point. And now we're going to multiply like there's no decimal at all. So 26 times 6. 6 times 6 is 36. We carry the 3. 6 times 2 is 12 plus 3 is 15. But we're going to have one number behind the decimal point because we have a 1 in parentheses. So we have 15 and 6/10 times. Again, we have like bases. They're being multiplied together, so we add our powers. So negative 2 plus negative 4 is going to make it 10 to the negative 6th. But our coefficient, once again, is not in that range, so we need to adjust by moving it once to the left. So we're going to get 1 in 56 hundredths times 10 to the, and the power is going to increase. We made our number smaller. In return, our power gets larger, and we get 10 to the negative 5th for number 3. Now let's go ahead and jump down to number 4. We have something in standard form, so we need to adjust it. So we're going to move it once, twice, 3 times, and this will be 3.9 times 10 to the negative 3rd. We just made our number larger. In return, our power needs to decrease by 3, just like we did in number 3. And now we can go ahead and regroup, just like we did in number 2. So we have 3.9 over 7.5, and then our like bases or our powers of 10, 10 to the negative 3rd over 10 to the 5th. Now let's go ahead and divide our coefficients. So we have 3.9 divided by 7.5. We first need to make sure that our divisor or the number on the outside is not a decimal. So we're going to move it once to the right. But in return on the inside, we also have to move this once to the right. So then we're going to get 39 on the inside, 75 on the outside, and now we can go ahead and actually divide these. Well, 75 doesn't fit into 39 at all, so we have to add in a decimal point and a 0 to keep going. I'm going to move that decimal point up into our quotient. 75 fit into 39 0 times, so I'm just going to add that out front. 75 fits into 395 times. 75 times 5 is 375, so we subtract, we get a remainder of 15. Well, 75 doesn't fit into 15, so we add a 0 here, bring it down, and then 75 fits into 150 twice perfectly, so we end up with a remainder of 0. So now we're working with 52 hundredths times. We then have like bases being divided, so with our exponents we're going to subtract. So this is negative 3 minus 5, which is going to give us 10 to the negative 8th, and then the only thing that we need to focus on is the coefficient by getting it into that range. So we move it once to the right, making our number larger, and in return our power then is going to decrease to the negative 9th. For our final answer for number 4, I'm just going to erase this so we have some space for number 5. So let's get rid of all this. And this was 5.2 times 10 to the negative 9th. And now on to our last one before we move to the practice session where you try 5 out on your own. So let's go ahead and adjust our denominator. 47,000 is not in scientific notation, so there's a decimal point behind the number if you don't see it, and we need to move it so it's in that range of greater than or equal to 1 but less than 10. So this is going to be 4.7 times, we just made our number smaller, we moved our decimal point to the left, so in return our power increases to 4. And now let's go ahead and regroup. I'm just going to do it over here on the left side. So 9.4 over 4.7, and then our like base is our powers of 10, 10 to the negative 11th over 10 to the 4th. Now we can divide. So we have 9.4 on the inside, 4.7 on the outside. Again, we need to adjust this by moving one place value to the right, and in return that happens on the inside on our dividend. And now we have 94 divided by 47. Well, 47 doesn't fit into 9, but it does fit into 94 two times perfectly. So 47 times 2 is 94. We subtract, we get a remainder of 0. So we get 2 as a final answer when we divide our coefficients. And then for our like basis, all we have to do is take our exponents and subtract them. So we get 2 times 10 to the negative 11 minus 4 is going to give us negative 15. And this fits into that range. Our coefficient is greater than or equal to 1 but less than 10. So our final answer for number 5 is 2 times 10 to the negative 15th. Now let's go ahead and make our way over to the practice session where you try 5 out on your own. Now we're on to the practice session. I encourage you to pause the video here, try out these 5 problems with multiplying and dividing with scientific notation, and when you think you're ready to go, come back and play the video and see how you did. So I'm assuming at this point you've tried out all 5 and you're ready to go over the answers, so let's go ahead and jump into number 1. So just like we did in the lesson, we're first going to regroup our coefficients and our like bases or our powers of 10. So I'm just going to do that on the right side here. So 4 over 8, and then we have in our other parenthesis 10 to the 7th over 10 to the 2nd. Now we can go ahead and divide our coefficients. So let's do 4 on the inside, 8 on the outside. 8 doesn't fit into 4 at all, so we just need to extend this by putting a decimal point and a 0. We move that decimal point up into our quotient. 8 did not fit into 4 at all, so we put a 0 there, but 8 fits into 40 5 times perfectly. So if we subtract 40 here, we get a remainder of 0. So now we have 0.5 times, and then for our powers of 10, remember that we subtract our exponents for division. So 7 minus 2 is going to give us 10 to the 5th. The only problem is our answer still isn't right because our coefficient does not fit in that range of greater than or equal to 1 but less than 10. So we need to move our decimal point one place value to the right, which makes our number larger, and in return our power should decrease by 1. So our final answer should be 5 times 10 to the 4th for the first one. So if you got that, nice job. Now let's go ahead and take a look at a multiplying one for number 2. So let's go ahead and regroup right away. 3 and 78 hundredths times 7 and 1/10, and then let's put our powers of 10 together. So 10 to the negative 4th times 10 to the negative 5th. We can go ahead and multiply our coefficients together. So we have 3 numbers behind the decimal points in total. So I'm going to put that on the side here. We have 378 times 71. 1 times 8 is 8. 1 times 7 is 7. 1 times 3 is 3. When we move to the next line, we add a 0. 7 times 8 is 56. We carry the 5. 7 times 7 is 49. Plus 5 is 54. Carry the 5. 7 times 3 is 21. Plus 5 gives us 26. Now we can go ahead and add. We get 8, 13. Carry the 1. We get 8, 6, 2. And then we should have 3 numbers behind the decimal point when we add it back in. So we get 26 and 838 thousandths times, and then for our like bases, we simply need to add our powers when we're multiplying. So negative 4 plus negative 5 is going to give us 10 to the negative 9th. However, our coefficient is not between that range of greater than or equal to 1 but less than 10. So we need to make our number smaller by moving it once to the left. So we get 2.6838 times 10 to the, and we made our number smaller In return, our power needs to get larger, and it should be 10 to the negative 8. So a little bit challenging of a question, but if you got that right, very, very nice job. Again, we're not worried about significant figures. We just want to make sure you can multiply or divide by scientific notation. Now let's go ahead and make our way over to number 3. So we have one that's in standard form. We first need to adjust it and get it into scientific notation. So let's move our decimal point once to the right, twice, 3 times, 4 times, so we get a number that's in that range of greater than or equal to 1 but less than 10. So that is going to be 5.4. Now we're making our number larger. We got a very small decimal and now it's 5.4. So in return, our power is going to decrease. So we moved it 4 to the right, which means our power needs to decrease by 4. So now that they're in scientific notation, we can go ahead and use the associative property to regroup them. So this is going to be 5.4 times 8, which is our coefficients. And now we can put our like bases or our powers of 10 together. So 10 to the negative 4th times 10 to the 2nd. And now let's go ahead and multiply our coefficients. So we're going to have a 1 on the side this time. And we're going to do 54 times 8. 8 times 4 is 32. We carry the 3. 8 times 5 is 40, plus 3 is 43. So we're going to have 43 and 2/10 times. For multiplying with like bases, we're going to add our powers. So negative 4 plus 2 is going to give us negative 2. We have to adjust our coefficient because it's larger than 10. So we need to move our decimal point 1 place to the right, which is going to make this 4 and 32 hundredths times 10 to the, and again, you're making your number smaller, you're moving your decimal point to the left, so in return, your power needs to increase to negative 1. Now let's jump down to number 4, where we have a division problem. We have something in standard form, that 24,000, so we need to adjust that. Our decimal point's at the end of the number if we don't see it, and we're moving it once, twice, 3 times, and 4 times. So we're going to end up getting 2.4 times. Now we're making our number smaller, moving the decimal point to the left. In return, our power is going to increase, so it's going to be 10 to the 4th. Now let's go ahead and regroup. 7.2 divided by 2.4 in one parenthesis, and then our other one's going to be 10 to the negative 11th over 10 to the 4th. Now let's divide our coefficients. 7.2 divided by 2.4. Again, we need to move our decimal point once to the right on the outside, which means we do that on the inside. So now we're going to have 72 divided by 24. 24 doesn't fit into 7 at all, but it does fit into 72 3 times perfectly. So we subtract 72, we get a remainder of 0, and this is going to be 3 times. We are dividing like bases, so we subtract our exponents. So this will be 10 to the negative 15th. Our coefficients between that range, so we're done with number 4. And then on to the very last one. Let's adjust our numerator here because it's in standard form. So once, twice, 3 times to the right, we get 9.3 times. We're making our number larger, so in return, our power gets smaller, so we should have negative 3 because we moved it 3 times to the right. Now we can go ahead and regroup. So we have 9.3 divided by 6, and then we have 10 to the negative 3rd over 10 to the negative 8th. Let's divide our coefficients. 9.3 divided by 6. 6 fits into 9 one time. 6 times 1 is 6. We subtract, we get a remainder of 3. Let's move that decimal point up into our quotient. 6 does not fit into 3 at all, so we bring that 3 down. 6 fits into 33 5 times. 6 times 5 is 30. We subtract, we get a remainder of 3. Well, 6 doesn't fit into 3 at all, so we bring a 0 down. 6 fits into 30 5 times perfectly. We subtract, we end up getting a remainder of 0. I'm just out of space. So now we have 1 and 55 hundredths times, and then with our like bases, we are subtracting the exponents. So negative 3 minus negative 8 turns to negative 3 plus 8. So we're going to get 10 to the 5th. And this is our final answer. Our coefficient fits in that range. Hopefully you went 5 for 5 in the practice problems. If you did, very, very nice job. I hope this video helped you out in multiplying and dividing with scientific notation. If it did, leave a like on the video. Comment any other topics you want to see in the future. Subscribe, turn on that bell for post notifications. And we'll see you in the next one with some more mathematics.
I came in a bit